Hello and welcome to another video from our BeamTool tutorial video series. In this video, we want to show you the usage of point respect function simulation for designing phase array inspection techniques. In previous videos, we introduced the concept of point respect function and show you examples of how it can be used as a powerful tool for designing full metrics capture inspection techniques, and how we used quality maps that we get from point respect function simulation to assess the quality of the inspection technique we design for full metrics capture. In this video, we want to show you that those quality maps can also be used when we are designing a phase array inspection technique. So here to start, from what you saw before in the previous examples, I have chosen a 5L64A12 and SA12 and 55S wedge, and we are looking at the double V weld bevel in a 30 millimeter thick plate, and we have already put a FMC beam set on, and I have already rendered the point respect function. And as you know, remember before, we can get the preview of the point respect function, and also we can turn on all those maps. Now what I want to do, I want to add a sectorial beam set for phase array. Here, just for the choice of comparison, I make a sectorial and I'll choose 16 element aperture. Here I turn on the element, so you see I will move this to the center of the probe, and I'll get rid of the second skip, and I will start to increase the angles, to cover the same area as was covered in the my FMC box, and just for the purpose of demoing the concept. Although we know that these high angles are not ideal, but here they're going to serve as a tool to just compare the differences. So here I turn off my FMC beam set, and I'm a sectorial beam set. Similar to our FMC beam set, we have a PA quality map. And here I can come and basically switch these first to point respect function preview and start the simulation. So the simulation is going on a background, and the point respect function calculation is being done in the background. And when it's done, we can see here, we can click on show beams, and we can see that we have the similar concept here as our point respect function. If I zoom in here in this box, you will notice that we have our point respect function preview also, but the major thing obviously that you see as a difference is that now the point respect function is much larger and much more spread out as we move here, and that's because when we use the 16 element aperture only, it's going to create a very diverged non-focused beam. And when you can see that when I turn on the FMC beam set, at any spot when they are compared, the indication that we get, or the point respect function that we get, would be much smaller and focused for the TFM image from the FMC capture, but it's a very diverged, spread out indication for our phase array as compared to the TFM. So this concept here at this point this example was chosen to just show you how we can also use point respect function for sectorial beam sets for phase array inspection techniques. Now let's look at another example of technique designed for covering this weld. So before I want to just show you that how we can use point respect function to assess focusing capability in the phase array inspection techniques. In this case, what I want to show you first is design of a compound scan, as we did before. If you remember before, we introduced the compound scan, which is the beam set that we can create different beams from different apertures. So here, if I choose my aperture size to be 16 and I spread my beams to start from, let's say, 46 degree to 68 degrees. So here it just, or maybe I can increase this. Here would be an example of the compound scan that is covering this weld. And here, what you will notice is for all the examples we showed you before, we had an option in top that always this option was none. This is where you can choose focusing option in BeamTool. We can choose to focus to a certain depth. We can choose to focus at a certain offset or half path or none, which was the case that so far we dealt with. Now, in this case, if I render my point spread function in my first leg here, what I get is the sense, and I can plot the beams on top. Right now, the point spread function is simulated only for the first skip, so I can turn off this. And what you notice is we have our sensitivity. Seems like our sensitivity is dropping actually at the location of these bevels, and we have a large indication as our point spread function. So if I go to our vertical resolution, you'll see that our vertical resolution is around 5 to 5.5 to 4. And this is what typically expected from unfocused phase array. And we always have, when we do analysis, we get oversizing because we are not focusing. We can do the same simulation in the second leg also. So if we say recompute, let's click this. We can do this for the second skip also. But the point is now, if I come here and add focusing, let's say now we come to a sectorial, in this case, a sectorial scan, and if our instrument low we use for all 64 elements aperture, and now I create a similar beam set, but this time with 64 elements. So I can come to like lower beams here and much larger angles to cover my bevel. And now in difference, what I will do, I will choose focusing and I choose projection focus. And that's where you will see these points, and these points show where actually I chose to focus. And that is something that I can control by the focus length here. If I increase the focus length, I keep moving the points to forward or backward. And here, if I choose, like, because the main goal is to focus along the bevels to improve the sizing, I choose the focus point to be at this offset, something around 5 millimeter before 0. That can work for both bevels. Now, in this case, if now that I have focusing, if I go and use compare and compare this to my spread beam set that was not focused. Let me just make sure. Spread beam set 1. So maybe first I'll just show you how it works. So if we just focus here, now the difference we will get is that we will have a much focused beam and much higher sensitivity. Right, so here, the interesting thing that you notice, and if I turn on the beams here, and I want to turn off my beam. So what you notice now is that because of the focus, at the area, the focal point where you set the focus, you have a much higher sensitivity and much smaller indication. As expected, as we go to the left, and right that go away from the focus, what will happen is that our sensitivity drop and also the size of our indication start to increase. But if our goal is to cover this well, what we can say, I have a confidence to say, is that we reached our goal of improving the sizing along the bevel by using a focus. So these help us to know that although we are dropping sensitivity, but this shouldn't be a factor that basically stop us from use focusing because of the advantage in the sizing and sensitivity we get. To directly compare this advantage from the case that we were not using focus, we can come here and use compare and compare our focused beam set with a non-focused beam set. And in this case, what will happen is BeamTool will split the view and try to render point spread function simulation for both cases, but it will try to plot those in the same palette range or color palette range. What happens in this case now, you will notice that if I turn this off, what now you will notice is because they're the same palette range, the palette is almost saturated in the focused case because it has much higher sensitivity and much higher amplitude. So if we zoom on that, you will notice that we have a factor of 10 increase in our sensitivity, and also you will notice that our point spread function is much smaller along the bevel. We can easily visualize that by, instead of sensitivity, switch to vertical resolution. When we switch to vertical resolution, now we directly measure the size of that point spread function around the bevel. And here you notice that when we use focusing, now our sizing along the bevel is in the order of 1.7, 1.8, 1.5, versus when it was unfocused, you're in the order of 5 millimeter. So this shows that this focusing, as expected, can improve our sizing by a big factor. And now, going forward, in the next examples, we want to keep using point spread function to show you that this can open up opportunities to use focusing and assess the improvement we can get for focusing, but also be aware of how our sizing sensitivity changes out of the focal area or the zone. As you see here, if we get past our focus to the left, now the size of these blobs start to approach to be similar because now we are not using the focus. Thank you for watching this video.